Recursive is exactly what you all tried to do the very first time I introduced sequences and series with you. What it is it's based, instead of based on term number, it's based on the prior term.
What? I don't like the term. Oh!
Okay, so this one's not based on the term number. This one's based on the term before it. Okay? Oh, dear Lord.
What if there's recursive? Does anyone have an extra?
When we write a sub n, I have one that's not I have a marker. Wait, Corbin, I have one.
Hey, Mark.
Oh my God, my throat.
When I write a sub n, I'm talking about a current term, okay? I'm talking about a certain term. So if I write a sub n minus 1, what that means is look back one term. Look back to the term before. Now, here's the key to recursive. You have to define initially your starting term, because if you're basing it on the term before, then you have to tell everybody where to start, right? So in other words, if I said a sub n, y'all got that?
Yeah.
Wait, what is that?
No. Our test is Friday.
While I'm here, if I said a sub n minus 2, that would mean look back 2.
Oh.
You see what I'm saying?
Yeah, what if it's
Just look back at it.
Well, that would be looking forward to do that. All right. No, you won't do plus 1 because that would be looking forward and you haven't figured those out. Okay? Now, well, you will, but you'll be writing rules based on the term before it. Guys. All right, so for example, if I said that a sub n equals 5 times a sub n minus 1. Tell me what that means. Look back at 1, multiply it by 5, and that's how you get the next one. Right? But if I asked you to write this sequence, you don't have enough information to do that yet. Why? You don't, because if you're trying to find the first term and it says look back 1, you don't have 1 to look back to because it's the first term. So you have to define, part of the rule then is defining the first term. So let's say a sub 1 equals, I don't know, 8. Well, now you have enough information to form that whole sequence. So it would be 8. What would the next term be? 40.
Oh, wait, hold on.
Wait.
You don't have to subtract by 1.
This is saying for this term, look back and multiply by 5.
What about
Okay, do you see what we're doing? No. This is exactly what you wanted to do when we started. And you said, oh, look, each number is increasing by blah, 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 or each number is multiplying by blah, 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 blah. Because that's an explicit rule, not a recursive rule. That was defined to start with. That's why I was saying you have to define it to start with.
So wait, so basically...
That does sound stupid.
But you're going forward.
You are going forwards, but this equation is saying, okay, so if I want to find, let's say 1, 2, 3, this is a sub 5, right? If I want to find the 6th term, so a sub 6,
Oh, you look at 1,000.
then it says 5 times a, well, n here is 6, right?
Yeah.
So 6 minus 1 would be 5. So what is a sub 5? It's 1,000. So 5 times 1,000 would be 5,000.
See, I could do this without.
Okay, so look at this one. What if I said, oh, yep. All right. A sub n equals 1/2 Now, if I give you this, tell me what I need to define. What the first and second, because this is using the two prior terms. So I'm going to tell you then that a sub 1 is 4 and a sub 2 is 12. How would you find the next term? 4, 12. So this says add the prior two. So 4 plus 12 is, and multiply by a half. Find the next term.
9. Wow, our super cool.
You see what we're doing here? And then we get into odd numbers, so I'm going to just put dot, dot, dot.
What?
Okay. How did you do that? Add the 2 before it and divide by 2.
That would be a
It is, yeah. All right, so yes, we're going to have to find the rule. That was getting your feet wet with some...
Oh my gosh, didn't make sense.
But they're easier to identify when you're basing them on the prior term instead of the term numbers. You will. Now, I will say there are a couple formulas on here. Recursive you can write even if they're not arithmetic or geometric. But if they happen to be arithmetic, the recursive arithmetic formula, and you really don't even need the formula. It's pretty self-explanatory. It's, because arithmetic means you're adding 1 each time, right? It's a sub n equals the prior term plus the difference, right? That's how you get to the next one, is adding a constant difference.
Wait, hang on, can I tell you? The prior term was the difference.
All right, look. This is an arithmetic sequence. Why is it arithmetic? Because from one term to the next, you're adding 10 every single time, right? So the rule for that would be a sub n equals what? What's the rule? A sub n minus 1. Look back 1 and add 10 because it's arithmetic. But you have to remember, I have to define the first term. If you don't, it's not a complete rule because you have to, given the rule, you have to be able to write the whole pattern. And if you can't, then you don't have enough information.
Wait, why did you circle ace of?
That's the arithmetic equation. Yeah, yeah. Okay. No. We're only going to do sequences. That's what I said. This is an easy lesson today. It should be. Should be. Take a look at this one. This one's going to be geometric. Did somebody say wait? Oh. The one I'm fixing to write. It's not there yet. All right, so this one's on your formula sheet as well. R, which is your ratio between the terms, times prior term. Remember to define that prior term, though. Okay, so maybe you should say, you should add in here that a sub 1 equals, and you got to define that. 16, 40, 100, 250, 625. Is it geometric, first of all?
Yes.
Yes, that's why I put it under geometric. What's the R?
What's 40 divided by 16? 2.5.
So 3 over 2? I don't know. Is it?
Yeah, it's 2.5.
5 over 2. So for this one, what we're doing is we're multiplying this one by 5 over 2 to get to this one, right? So a sub n equals 5 over 2 times look back 1. But I need to make sure that I define the first term. Does that make sense?
5 over 2 is 0.4.
No, 2.5.
Do you have to define it for the other term too?
Oh, I see where you're coming from.
Yes.
10.
For all recursive, you have to. But explicit, no. All right, let me show you one that you have to be a little more intuitive about. These are the fun ones. You ready? The first one I'm going to show you is a famous sequence. What? Yeah.
Is there a sequence in the world? Is it?
How'd you know?
What is it?
I'm just smart.
The little rocket warriors. The little rocket.
Wait, is that?
Sounds dumb.
What's the next one?
I don't know.
Oh, you don't know it. You
I
just...
don't know it.
Fuck.
That's the only fucking sequence I know.
Not Liberace.
I think it was.
Okay.
Wait, that's the Fibonacci.
We just had this whole conversation.
I said first.
Wait, Miss McGee. Is that the Fibonacci sequence?
Yes.
Oh my god.
Y'all are so silly. Okay.
I am silly. These guys all try to.
It's a recursive sequence. Okay, so how would I define it?
A sub n minus 1. A sub n minus 1 plus the previous term.
How you said previous.
A sub n minus 2. 2.
But you're not done because you have to define. Is that it?
Yeah.
No, I need 2 terms to start because you said look back 1 and look back
A
2.
sub 2 equals 1.
Now you could write the whole sequence.
Dude,
That's
this
pretty
is
cool,
me,
right?
I'm making my way off.
You want to try one? Okay.
I don't know if I'm smart.
Sure you are. All right.
Never mind.
Okay.
Oh, we have a nail second one.
This is easy too.
Hey. Oh, so, man. This time's 2. No, it's not.
All right, Joseph wants a crack at this one.
I can't figure out I know a sub n equals a sub n. Alright, hold on. A sub n minus 1.
Okay.
Times a sub n minus 2.
Then you have to define.
We're fine. So then it's a sub 1 equals 1. A sub 2 equals 2.
Good job.
Wait,
That was an easy one.
No, it's not. I don't
Ready to burst my bubble? You did that recording.
Yeah. Let me see what happens if I kind of mix recursive and explicit together a little bit.
No. Let me try it. I dare you. That's impossible.
You dare me?
Wait, hold on. Let me write this down. I have to have a
I need to go to the bathroom and take a shower to cover myself up.
What are you looking for?
A hard one?
I thought about wearing this.
I got a hard one. Wait.
Hard, but I don't want to make it. I'm trying to not to make it too difficult for you.
Wait, can you have my this week? Can we have like an a sub 1 n minus 1 times a sub n minus 2
I thought it was
plus
saying ace the
a
whole
sub
time.
n minus 1.
That's what you find.
Yo, look what I brought the today.
All right. See who can get this one first, but don't blurt it out when you get it.
Okay.
You haven't had a chance to.
I'm good, I'll pass first.
No. Tell us what you did.
Square.
It doesn't sound like it.
Square.
Hey, cool, you got it. Wills, you got it.
Wills, what did you do?
Hold on. Oh my god. Because I'm writing it.
I really need to dust.
Oh.
Hold on, I'm checking this shit.
I need to dust.
A sub n minus 1 times.
Can I write this
Is
down? Is
it
it
a
right?
sub n minus 3?
No, I got.
What's your plot? Is it?
So that would mean you'd have to define up to 3. For this one, it'd have to be this times this. Note.
Wait, hold on. Can I try mine?
Okay.
Hold on. I don't know if it works. I just kind of wrote it down. I don't think you should do this. Alright. A sub 1, A sub n minus 1, whatever it is.
Mm-hmm.
Plus the same thing. I don't want to say it again.
So how do you know if this
N
is?
minus 1 sub n minus 1.
So 2 times a sub n minus 1.
Yeah. Times a minus 1. Hold on. Hear me out.
That's okay. We're going to write it and then we're going to check it.
It says 2 times 1 times 1, which equals 1 again.
Wait, times what? 2 times the prior term
Yeah.
times.
Times the same thing.
So 2 times a sub n minus 1 squared?
No. Wait, hold on. No. No, hold on. Let me rework this. I have it in my head and it works. But I actually.
Okay, this does not. Anybody else got anything else?
I don't know if it works.
The 2.
What you got, Kirkland?
A sub n minus 1 times 2 a sub n minus 2. That's what I put.
Times 2. What?
A sub n minus
Times a sub n minus 2.
2. Yeah.
So multiply the 2 together before it and double it. All right, so here that would mean go before, multiply and double. That works. Here, this one and this one, 1 times 2 is 2, doubled would be.
Wait, I know what to do. I think I know what to do. Is
Is it
A
double
sub
times
n? Is it a sub n plus a sub n minus 1 or n plus add minus 1?
A sub n,
Minus 1. Sorry.
Yeah.
I'm confused. Plus a sub n minus 2. Multiply that to?
like this.
Wait, I think I have something.
Or is it 3?
All right, so that would be 1 plus 1,
Wait.
which is 2, so that doesn't work.
Wait. Does it go up each time?
Let me give you a hint. Let me give you a hint. Do y'all want a hint?
Make the multiplication go up.
Corbin, I was counting on you.
Look.
Y'all want a hint?
1 plus 1. Okay. 1 plus 1 is 2 times
really
1
Oh,
times
she said she mixed.
1 times 2
Oh.
times 2. Wait, 1 times, I mean times
Oh my gosh.
3.
I got it.
Palmer, stop. You're
Is it a sub n saying
I'm just going.
A sub 5.
A sub
Divided
n
by a
plus?
sub 5.
Say again, say again, say again.
A sub 5. Or n minus 5. What?
Oh, no.
N minus 5.
Did you just do it? Just do it. No one can bring it. We have 3 minutes.
I actually think I like it.
We don't get out till 9:50 today. It's late arrival. A sub n. Shh, shh, shh.
Hold on, wait, hold on. One more minute.
No, just do it. Just do it. Yeah, obviously.
N minus 1.
Are you kidding me? That's the whole thing.
Does it work?
So first term
For this one,
Wait, I don't see it.
It's not right, you didn't write the term, the first
No,
term.
I think
No, this was confusing to me. I can't.
yeah, because one.
Ms. McGee, why would you give us an example?
No, 6 times 4.
it is n minus 1.
Yeah, it has to minus that one.
It's look back, it's these two numbers multiplied by themselves for the next term. So if you look back 1, you also have to look back 1 on the term number itself. I thought writing those numbers under there would give it to you.
It's still not right.
My way technically
It's still
works.
not right.
If you think about it, my way technically works.
Ms. McGee, it's still not right.
Yes, it is.
It's not. You didn't write the first term.
Oh, you're right. You're right. You got me, Wills. You got me. All right.
Homework.
That's it.